Welcome to welcome to part 9 of this machine learning bootcamp. It has been quite a time since I've uploaded a video on YouTube, but still I have the same enthusiasm and motivation that I had when I started the YouTube channel. So in this part of our bootcamp, in this video particularly, I will focus on random forest trees. I have finished random forest trees based on regression but in this video I'll focus random forest trees based on classification. So classification based random forest trees. So in this video I'll focus on classification based random forest trees. Most of the things are same. There will not be a lot of changes from regression based and classification based random forest trees, but there will be slight changes in how we are going to code our random forest trees. Whatever I have explained in regression based random forest trees, all the concepts are same as classification based random forest trees, but the only thing that is going to change is a little part of the code. So in this video we will see more on what is precision, accuracy and more new stuff in classification types. So let us see. But if you haven't seen regression based classification video, then please do check it out, because that video is a prerequisite for our this video. If you have a thorough understanding of that video, just that's enough to understand easily what we are going to do in this part of machine learning bootcamp. So let's directly jump into the code of random forest trees based on classification. So click on new notebook over here. Let us name it random forest trees classification. So the first step in any code is importing libraries. Now code. The three libraries we always import is pandas as pd, import matplotlib.pyplot as plt. We use this library to see the graphical representation of our classification. Import numpy as np. We use numpy for mathematical calculation on n-dimensional array. So now fetching the data code pd dot data is equals to pd dot read csv. Let us import the data. Let us choose this file, open it, okay, and then copy the path over here, bam, that's it. And then we are going to divide our data as usual into dependent values and independent values. X is the dependent variable values, which is data dot ilog. Let us open this CSV file and see what it is. Yeah, this one is our CSV. Yeah, so this one is our CSV file. We need all the rows. So this means we need all the rows, and we need all the rows from here to here. For this video sake, I'm just removing this state state column as it doesn't contain any categorical or numerical data. So so x values from here 0, 1, 2. Blank space means 0 from 0 to this 1, 2 up till second column, and y is similarly y data dot ilog. Need all the rows from 0 to last row, and we just have one dependent variable value. This one, profit, is our dependent variable, so -1. Oops, -1. Oopsie, I have done a mistake over here. Let me fix it. Fetch the data. Yeah, that's it. That sounds good. Let us run this and this. Yeah, fantastic. Now let us see the values of x and y. Shift enter. What is okay? It's capital X, right? Sorry. Yeah. So these are our values. These three columns, it's our x dependent variable value, and the last profit column is our dependent variable value. That's it. Now it's time to split our data into test set and training set. Splitting the data into test set and training set. Good. Import sklearn.model selection. So from sklearn.model selection, import train test split 4 variables, that is x train, x test, y train, y test is equal to train test split. We want to pass x and y, and the test size, let us give it as like maybe 25%, right? Anything between 20 to 30% is good. So let us give 0.25, that's 25%, and the random state, let us it be 3, because what does random state 3 mean is that we are taking this 25% of the test set anywhere from the whole data set. Like, but if you take random state as 0, then first 75% is going to be our training set, and the next 25% is going to be our test set. So let us run this one. Run. Good. Let's print out our value. Y train, got the spelling wrong. Yeah, and x test, y test. Yeah, we got all of these values. Text. So if you see these values, the ranges of these values are very big. So what we can do is we can scale down this value to a value between -1 and 1. So for that we can use a pre-processing tool called as sklearn. So what we can do for pre-processing this is we can use a standard scaler. So scaling the ranges to lower ranges. from sklearn dot pre-processing import standard scalar. I have actually explained standard scalar in my first video of machine learning bootcamp. You can go and check it out for more clarification. So let us create a standard scalar object. Let us name it as SC is equals to standard scalar. Got to run this, run it. Yeah. And the new x train values are going to be x train is equal to se dot fit transform x train. So fit means we are going to fit these values between the range -1 to 1 based on our training set, and then transform these values of training set. Now our test values, x test is equal to sc dot fit, or not fit, just transform. We have fitted our model on our training set, we just have to transform it. Now I don't know why is it giving me this thing. What is it? Yeah, transform x test. Let us run it and let's see the values of this. Let us see the values of x train and x test. Code x train x test. As you can see, we have reduced the range of these values from these big values to like this values has become like these small values now. Now let us create our classifier object. Creating classifier as a textual, like a text. Creating classifier of random forest from sklearn dot ensemble, because from in this ensemble library we have random forest. Why is Google Colab not giving me it's giving me. Then let's create our classifier is equals to random forest. Why is it not giving me any hint, mate? Yeah, good. So it takes parameter as an estimator, that is an estimator, as you can see over here. So what this an estimator parameter does, it tells how many number of decision trees we want to create for our classifier model. So let us say, like, I'm keeping it 10, what I have done in random forest regression. So let us now train our model. Classifier dot fit x train, that's it, x train comma y train. An estimator version got an estimator. Oh yeah, it's an estimators. Yeah, and let us now run it. Okay, unknown label type continuous. Okay, I understood why we are getting this error. So it's showing value error, unknown label type continuous. Okay, now I get it. Why is it giving unknown variable type continuous? We want classified values, like classified or categorical values, not this continuous values. It should be like 0, 1 or 3, but not this continuous decimal values. This is wrong. It's good that we have found the error, and it's also a benefit for the viewers to understand that why we are getting these types of errors. It's a good learning thing. So let us change our data set. So let us now open it and then copy the path. Yeah, let's copy the path over here, paste it, and let's open and see the data set of this data. We have two values, so we just have to include this thing, the last value, because this is our dependent variable value. See, as you can see, it has like non-continuous values. We have categorical values like 0 and 1, just binary values. Let's run it. That's it. Run all. Let us run all. Seems no error whatsoever. We finally got our classifier object. Ta-da. We finally got our classifier object. That's a good thing to know. We finally got our classifier object. It's a very good thing to know that we have resolved the error. Now it's time for predicting values on test set, right? And then code. Let us give it a name. Ypred is equals to classifier dot predict. So this and we are going to predict our x test values, right? Let's print out our ypred values. Ypred. So this is our ypred value. So let us now compare our predicted value with that of our original y test values. Comparing original value with predicted value. Code. So now let's do our comparison. Np dot. Let me make sure that these are not series. Yeah, it is series. Dot values. Dot values. For NumPy to concatenate these values, it should make sure that these are not in series like this. Now after adding values attribute, we can use NumPy to perform concatenation operation. Concatenate y red comma y test. Let us run it. So as I told, these are in integers, so we have to run all of these. Series object cannot be interpreted as an integer. So now it's taking ypred and ytest as series values. As we have already changed it into dot values, we have to convert ypred and ytest values also to the integer values. So we have to run it all. Run all. only integer scalars arrays can be converted to scalar index. So yeah, I forgot that concatenate has two parentheses at, yeah. Now we got our ypred values and ytest values. Let us now differentiate our ypred and ytest values. Comma 1 dot reshape -1 comma 1, same as here, dot reshape -1 comma 1. We are converting rows into columns and columns into row. That's it. For side by side comparison, we have to add 1 over here, not here. Here. That's good. I hope it works now. Yeah. See, look at here. We got a prediction. This is our predicted value, and this is our original value. This is the predicted value, and this is the original value. We got it same. This is a good prediction. This is a good prediction, and this is a wrong prediction. These are wrong predictions. So now let us find the accuracy. For this, let's go to sklearn API and click the first link, and we have to find accuracy, right? Accuracy score right over here, and this is what we need. Let us take it, copy and paste it over here. You know the syntax: from import, and before this dot we are importing accuracy score. And also along with this we can also take metrics, not importing, the syntax is import this, and also metrics. Was it showing a problem? No problem at all. And accuracy score is equal to accuracy score, which takes original value test ytest comma ypred. Let us run it. So there is nothing like accuracy matrix here, so we need confusion matrix, actually confusion matrix, not matrices. Is it correct? Let's go to our API and let us see confusion matrix. Yeah, correct, absolutely right. It takes confusion matrices original value and predicted value. Original value and predicted value. Matrix, and let us run it. Good. So our accuracy is going to be print accuracy Hmm, 84% good accuracy. And now confusion matrix, CM is confusion matrix. It takes original value ytest and ypred. Print CM. This chart clearly explains the confusion matrix. So the actual value and the predicted value, both we got as 57. The predicted and the correct answer we got as 57, and the actual value, which is 0, and the predicted value, which is 1. We got here 8 over here, as you can see, same as with the original value 1. For the original value we got 0. How many of them we got? We got 8 of them, like that. We got 8 of them like that. We got 8 of them like that. And for zeros we got how many zeros? This last term, for correct the original values of zeros and the predicted values of zeros are 27. And that's it for random forest classification. If you really like my video, please do like and subscribe my YouTube channel, as it motivates me to make more of such content. Signing off, Salman in Tech.